Good afternoon. This is Dr. Paget. You might remember me. I was at your school last week. Let's take a look at some of you all. So you might remember this. See, can you recognize? See anybody you know there? See anybody you know? You might see some people you know. Last week we were outside and are collecting data. You all did a good job. You were well behaved and you were doing science. You were out there doing science, you were looking at clouds, you were taking air temperatures, you were taking surface temperatures. Look at you all. You look like you were serious. You were on the playground, but there was no plan happening, work, and that's a good thing. So you all are looking at the thermometer, getting the thermometer readings, right? And so what we did here at Tennessee State University was we took your data and we created maps. And you're going to see your school on a series of maps. But first, my students are going to come up and introduce themselves before they present the maps to you. Okay? And so we are going to have our students come forward. They're going to tell you their names, their majors, what they're studying here at TSU, and where they're from and their classification. That's what they're going to do. And they're going to. All right, here comes first student.
Good afternoon. I'm Callan Peterson. I'm from St. Louis. My major is business administration with a concentration in marketing, and I'm a graduating senior. Meaning I'm out of here next week.
Congratulations.
Good afternoon. My name is Victor Yoon. I'm a freshman psychology major from Memphis, Tennessee.
Hello, I am Maria McElroy, a junior studying agricultural science, concentrating in environmental science from Detroit, Michigan, and I'm a junior.
Okay, let me slide back over here. So now we're going to show you all the maps that we made using your data. You're the stars. You created these maps. If it wasn't for you, there would be no maps. And we would like to thank your teacher, Ms. Smith, your math teacher, especially for letting us work with you all. So I'm going to pull up your map. Okay, so first we're going to have Ms. Peterson come up, and she's going to show you some things on the map. So I'm going to trade places here. Okay, so Ms. Peterson, would you go to content and go to that, take the check mark off of that second layer just for a moment and click on the first layer, click on change style. Yeah, that's right there, change style. Change that to Ida B. Wells Elementary School student.
Right here.
So it's IBWES student.
Huh?
Scroll down. Click on it again. No, not there. Right there. Right. See where.
Oh, yeah.
Scroll. Yeah, there you go. All right. Wait a minute for it. Okay, hit done. Get the bottom done. Go to legend. Okay, zoom out just a little bit. A little bit more. Okay, right there. That's good enough. Okay, so we have D'Antoine, David, Jeremiah, Jacob, Jaden, and Casey. We have their data. So Ms. Peterson, can you click on those dots so that the students can see their data? Okay, whose data is that?
D'Antoine.
No, in the pop-up window. See where it says student's name?
This is Casey.
So there's Casey's data. in the pink, I think. See the little arrow at the top of that box? Yeah, click that one. Okay, whose data is that?
This is Danton.
Yes, D'Antoine's data. Very good job, D'Antoine. Let's look for some other students' data. You can close that box and click on any of those dots, those point symbols. Okay, whose data do we have here?
Jeremiah.
Jeremiah, good job, Jeremiah. Let's look at somebody else's data.
This is Jaden.
Jaden, see your data, Jaden? See your dot there, Jaden? Close that one. One more.
And this is Jacob.
And Jacob's data. Close that box. So zoom out a little bit more, a little tad more, so you can see your school there on the this will be the left side of the screen, hopefully, and you can see the playground. How many of you all can see that? Yes, yes, you can see the playground. Okay, so we see where your data points right there, and we used global positioning systems, GPS, to determine those locations. Remember that? Remember we had the GPS receiver out there? Okay, so we're going to switch pilots now. We're going to have Victor come on up. Okay, so now we're going to change the map just a little bit. Okay, so Victor, go to content and put the check mark back on that second layer. Okay, now just click on the first layer. Go to change style. Change that one to average surface temperature. And then wait for it. Wait. Let's see. Hit options. Right there in the middle. Options, symbols. Let's go to fill. Change that fill to yellow. All right, and hit OK. Go back to symbols again. Make the transparency maybe. Transparency about 40%. Okay, hit OK. Wait for it. Okay, hit OK now. Hit done. Now go to that next layer. Change style. Change the style. It's already at current temperature, so it's blue. Hit done. Go to legend. Okay, zoom in some. Keep zooming. Keep zooming. Okay, wait right there. Okay, now Victor here is going to check, look at your data and tell you which student got the highest temperature. And then so let's watch Victor go through the process.
KC's sitting at about 27 degrees
Celsius.
27 degrees Celsius for Jeremiah too. 27 for Jaden as well. And 27 for Jacob too.
Okay, what about that last one?
Right here.
No, the last. Did you click on all four of the symbols?
Is it?
Okay, click on the one that has several circles in it. Okay, looks like there's some more data there. See that arrow at the top? Across. Whose is that?
David right here. David is at 26 degrees Celsius.
Okay, so, and which temperature was that? Was that the temperature that we got using the blue thermometers or the red infrared wavelength thermometers? Yes, actually, it's the infrared radiation thermometers, those red ones that we let the grown-ups use. That's how we got this data for the surface temperature. Okay, so you all are, well, we'll do that in a minute. So next we're going to have Miss Aria come up, and she's going to show you even more things about your map in a moment. Okay, so we just looked at the surface temperature. So that's the temperature on the ground. You can zoom out a little bit more. It looks kind of distorted. Okay, that is, okay, we'll just keep it there. So you can see we were on that sidewalk. Okay, we're on that sidewalk. Let's see, this is a little complicated. So go to content, take that first layer off. Yeah, now go back to legend. Okay, so now we have the current temperature. So let's see who got the highest and lowest current temperature. So who is that?
So,
Yeah.
Antoine, 27. Well, 23.
Okay,
David, 22.
okay,
Jeremiah, 22. And Jacob, 22. Okay.
okay, Miss Aria, can you tell the students how we can look at the map symbols and tell whose temperature was higher and whose temperature was lower?
The bigger the circle, the higher the temperature.
Yes, one day when you're older, you'll take a geometry class. And how would we describe the size of those circles from a geometric standpoint, Aria?
Diameter?
Yes, the diameter is larger for the warmer temperatures than the cooler temperatures. Okay, so Aria, please bring the other layer back up. Okay, so you all are in a math class, right? So now Miss Aria is going to give you a little math lesson with regard to the difference between the concrete temperature and the air temperature. So she's going to tell you a little math lesson without giving you the answer, because you have to figure that out. What we want to know is how can you determine the difference between your surface temperature or concrete temperature and the air temperature?
So different between this one and this one?
Yes. How would you form that into a nice little math problem for our students in Miss Smith's math class?
Not sure.
Okay, so let's start off. What is our highest temperature for the sidewalk?
The surface temperature?
Yes.
The highest is 27
Degrees.
Celsius.
Okay. And what was the lowest out of all of our students? Who got the lowest air temperature? Does that look like Jacob?
I think it was Jacob.
So what's Jacob's air temperature?
22 degrees Celsius.
And so what was the highest sidewalk temperature?
27 degrees Celsius.
Okay, I want you all to do a math problem Ms. Smith will help you, and we're gonna find the difference between the sidewalk temperature and the air temperature where we are breathing in air most of the time. Okay, can you do that? I'm sure you can. While you're working on that math problem, Miss Aria here is going to tell you why we should be concerned about that sidewalk making temperatures hotter. Why should we be concerned about that, Miss Aria Kelroy?
Because concrete creates more heat in an area, so areas like downtown Nashville or other downtown areas are gonna be hotter than in like in the inner city, because there's more green space, hopefully in the inner city. And it being hotter on the sidewalk can cause heat-related illnesses.
Okay, Miss Aria used a lot of really big words there. So maybe she can tell you again why we should be concerned, so that you fifth graders might be able to better understand.
So in the like a downtown space, the sidewalk temperatures are going to be higher because of the concrete surfaces and the sun beaming down on the concrete. And if you're in the inner space, like the area around the school that has a lot of grass and trees, it'll be cooler because there's less hard concrete for the sun to bounce off of.
So all that heat, Miss Aria McElroy, environmental science major, why should we be concerned just because it's a little somewhat hotter when there's concrete and streets?
Because it relates to the urban heat island effect, which is when it's really
Wow,
hot.
urban heat island effect. That's a really complicated scientific term. Can you like maybe simplify it a little bit, Miss Aria?
The urban heat island effect is when a urban space like the city of Nashville or other large cities have a lot higher temperature than the inner city because of all of the hard concrete surfaces and less trees and grass for the sun to be absorbed by.
So in terms of our health, how could that affect our health, that heat?
You can get heat-related illnesses like a heat stroke, which causes you to feel kind of tired and can lead to other more serious health issues.
And what other health problem that a lot of children have might be made worse by the heat?
Asthma.
Yes, asthma. I'm sure that all of you know somebody who might have asthma. Maybe it's a cousin, maybe your brother or sister. So that's why we study heat. That's why we're not just doing this. This is not just for fun. You all, it's time for fun, and it's time for science. But science can be fun too. Okay, thank you, Miss Aria. Let's see who went first. Oh, Peterson, who's graduating from TSU next week. So Miss Peterson is going to give us some more math because you're a math class and we love math, right? You can't do anything without math. Okay, so I'm going to start it off here. And Miss Smith, your math teacher, is going to help you out. But what I'm going to do is give you a few hints, and then Miss Peterson is going to develop a math problem for you. Okay, so here are the hints. Now notice that all of these values, all of these numbers are for all of these temperatures are in Celsius degree, right? That's the metric system. I'm sure your math teacher told you about that. Do we use the metric system a lot here? No, probably not at all. But every other country in the world, except for ours, uses the metric system. So sometimes, so we have to know both. It's just like how if you were in another country, you have to know English and that country's language, right? So we have to know both the old system of measurement and the new metric system. So here are some clues. 0 degrees Celsius is about 32 degrees Fahrenheit. Okay, you got that? 0 degrees Celsius. You might be right. You probably should write this down. 0 degrees Celsius is about 32 degrees Fahrenheit. And what do we know about 32 degrees Fahrenheit, right? What about 10 degrees Celsius is about 50 degrees Fahrenheit. Okay? Got that? Now, 20 degrees Celsius, which is close to the temperature that we found for the air, is about 70 degrees Fahrenheit. It's not exactly, it's about 70 degrees Fahrenheit. Then there's 30 degrees Celsius, and Miss Peterson is going to tell you what you need to do, perhaps, in order to calculate what 30 degrees Celsius is in Fahrenheit degrees. Okay, so Miss Peterson, 0 degrees Celsius is about how many degrees Fahrenheit?
32.
And 10 degrees Celsius is about how many degrees Fahrenheit?
50.
And 20 degrees Celsius is about how many degrees Fahrenheit?
7.
So Miss Smith, your math teacher, is going to help you figure out or calculate what is equal to 30 degrees Celsius. Okay, so she's going to help you do that. Now it's time to do some math. And then one of you all should tell Miss Smith, your math teacher, an answer to that. So thank you, Miss Peterson. Now we're going to have Victor come back up here. And he's going to show you some other interesting things about your data. Okay, so go to content and change both layers to, no. Just click right on the layer. There you go. Change that. Go to change style and change that to cloud type. Well, let's do first change 1 to low level cloud. Yeah. No, wait. I guess we did. Oh, no, let's not do that. Okay. So we'll be looking at this some more. Okay, so Victor here is going to show you all, we're going to talk about clouds. Can you zoom out a little bit, maybe a lot of bit. Okay, so now we're going to look at our cloud data. So what types of clouds did the students find, Victor?
We have altostratus clouds and stratocumulus clouds.
And then somebody saw how many low-level clouds?
2.
No. Somebody saw, some people saw stratocumulus. Some people said there were, see the red dot in the legend under low-level clouds? Yeah, some people said that there were no low-level clouds. Some people said there were. So we had a little conversation, remember? We were debating back and forth over whether or not there were low-level clouds or not. And some people said that there were, some people said that there weren't. So let's click on some of our students' data. Let's see, Victor's gonna tell us which students found what types of clouds.
Casey said that she found altostratus clouds.
Is that mid-level or low-level?
Those are mid-level clouds. And she found none for high level or low level.
Okay, oh. Who's this?
David also found altostratus clouds.
Who's this? Who's
This is D'Antoine. D'Antoine also only saw altostratus clouds.
did D'Antoine see any low-level clouds?
No, he did not.
Okay, who's next?
David only saw altostratus clouds, no low level clouds. This is D'Antoine.
Okay, I think that was everybody. So,
This is Jaden right here.
oh, Jaden.
Also only saw altostratus clouds.
So Victor here is going to tell you, what he's going to tell you is why having more than one person collect data when we are doing science. He's going to tell you why it's important that we have more than one person collecting data.
It is important to have more than one person at all times, so data is more reliable, and it varies. Every person, they find different examples, or they have different answers.
Yes. So, Victor, were any of the students wrong here? Did they have wrong answers? Did anybody have a wrong answer?
No, there are no right or wrong answers.
Yes. So when we do science, you can't be afraid to make a mistake. Every scientist makes a mistake. Sometimes in science, when we make a mistake, we discover new things. There are lots of, I'm sure your math teacher or one of your science teachers, if you have one, can tell you about several scientific discoveries. One is something called penicillin. Penicillin. You know, ask Miss Smith to help you Google penicillin, and you'll find out that that's a very important thing for us that was discovered completely by accident by someone who was a scientist doing science. Okay, I think we have, thank you, Mr. Victor. So we have Miss Aria coming back up. So Miss Aria is going to go to a different map. So you see the globe map up there, the globe tab way up in the top. Yes, that one should be okay. So this is a different map. This is another map that we call an aerial photograph. It's a photograph taken from the sky, probably by a satellite that's orbiting the Earth. And you can see the schoolyard. Can you see the playground? Can you see the roof of the school? And those two yellow point symbols or dots, that's where we collected data. So this is going to show us the same data that you collected, but a different way. We might not see your names this time, but we're going to see the data in a different way. So Ms. Ari is going to click on the northernmost point, and let's see what we have there. Okay, so Miss Aria, what is the average? Miss Aria is going to tell you what the average surface temperature at that point is first. What's the average surface temperature?
27.5 degrees Celsius.
And what was the surface cover type?
Concrete.
So remember that concrete, Now that 27.5 degrees Celsius, that's higher than the data that was on the other map, which is interesting. So now Miss Ari is going to show you the temperatures that we found using the liquid filled thermometer. You're going to go to that box where it says, the drop down box where it says surface temperature. And now we're going to go to air temperature. Let's see what we get there. Okay, Ms. Arya, tell the students what the air temperature was that day.
22 degrees Celsius.
Okay, so Miss Arya, could you please tell the students how they could use math to figure out how much hotter the sidewalk is than the air that we breathe?
They could subtract the surface temperature from the air temperature.
So what was the surface temperature, Miss Arya?
27.5 degrees Celsius.
And what will we do to determine the difference between the air that we breathe and the sidewalk temperature?
Subtract the 27.5 from the 22 degrees Celsius.
And Miss Arya is not going to tell you the answer. You have to figure it out by yourself. And you might be surprised. That's a pretty big difference in temperature. Because remember, 22 degrees Celsius is close to 70 degrees Fahrenheit. So think about how much warmer 27.5 degrees Celsius is than 70 degrees Fahrenheit. And Miss Smith, here's Miss McElroy is going to tell you all how you can convert these numbers into more familiar temperatures so that you could see the difference in those temperatures, perhaps in degrees Fahrenheit.
22 is about 70.
And she's not going to tell you the rest of that, okay? You're going to have to figure that out for yourself. But Miss Smith, your math teacher, is going to help you, because when you change the numbers to degrees Fahrenheit, it'll be more familiar to you. And then you might be really surprised how much hotter that sidewalk is than the air that we breathe. And you might be even more surprised when Ms. McElroy shows you this. Go to cloud. Look at our cloud. So Ms. McElroy, okay, let's close that box now. Let's go to the other, and let's hope that whoever did the other observation included the cloud measurements. Okay, well, there's some clouds there. And let's see if the satellite matches. Maybe we'll get lucky today. Let's see if the satellite matches. See, it says satellite matching. Just scroll down. Up. See it open in the window. And well, the satellite match isn't there, but if you remember, it was completely overcast that day. We could barely see the sun at all. And so even though the, go back to the globe map, even though the sky was cloudy and the sun was almost covered up, we still saw a pretty wide difference in temperature, right? So Miss McElroy is going to tell you, perhaps, exactly how that sidewalk gets warmed up by the incoming solar radiation. It's not actually the sidewalk that gets warmed up, it's actually gases in the atmosphere that warm up. And so Miss McElroy is going to explain that, perhaps. Okay, I'll help Miss McElroy. Miss McElroy is really smart. So Miss McElroy, what kind of radiation, that's a big word. Might have to look up that word radiation. What kind of radiation comes from the sun? Short wave or long wave?
Shortwave.
What's another word that we use for shortwave radiation? You kids, if you're ever outside, maybe your auntie or your dad or your uncle or your grandmother will rub some sunblock on you, and there's a number on that sunblock. It's called the what number, Miss McElroy?
The SPF or the UV.
What does UV stand for?
Ultraviolet.
Yes, so ultraviolet radiation comes from the sun, but it does not warm up the Earth's atmosphere. The Earth soaks up all that shortwave radiation. So the shortwave radiation comes in from the sun, the Earth soaks it up, especially that concrete. And then it releases that energy. Is it shortwave radiation, Ms. McGill? What kind of radiation comes from out the ground, from the Earth?
Long.
Yes, long wave radiation. And we also sometimes call that infrared. I know that's a long word. Infrared radiation is long wave radiation. And sometimes we call that thermal radiation, right, Ms. McElroy? And so that radiation leaves the Earth, but in order for the atmosphere to become warmer, the atmosphere or the air has to soak in that energy, right? But there's only specific gases that can hold that hot, that energy. What's one major gas that can absorb that energy and can warm up the Earth's air and atmosphere, Miss McElroy?
Carbon dioxide.
Carbon dioxide. Which is CO2. Maybe you'll learn about that later, maybe in elementary, maybe in middle school. Carbon dioxide. What kind of gas is carbon dioxide? There's another gas called methane. What do we call those gases, Miss McElroy?
Greenhouse gases.
Greenhouse gases, right? We all know what a greenhouse does, right? It makes things warmer so plants can live inside, even in the wintertime. Okay, thank you, Miss Aria. Thank you for helping us out. Let's have all three of my students come and get into the frame here. The camera, we're going to say goodbye. So wave goodbye to Miss Smith's 5th grade class. And thank you very much for your presentation. And so hopefully you had some fun today. I want to thank you students, you 5th graders, all of you 5th graders, and I know that not everybody had their information on the map, but maybe the next time that we come back to your school, maybe we'll get all of the students' names on the map. So I'd like to especially thank D'Antoine, and we'd like to especially thank David and Jeremiah. Way to go, Jeremiah. And Jacob and Jaden. And we have one young lady, keep doing science, Casey. Very important that girls do science too. And so thank you very much. And hopefully we'll see you right here at TSU in about 8 years, 9 years, something like that. Thank you very much. And we are going to sign off. Have a great rest of your school year.